Hello, everyone. Thank you for joining us for this webinar today. My name is Sukhpreet Bedi, and I also have Adarsha Kuturu with me. We both are database specialist solutions architect here at AWS, and today we will talk about tackling the major version upgrades, planning the DR strategy, and some more capabilities of Amazon RDS read replicas. During the webinar, feel free to ask questions via the sidebar tool, and we will also have some time at the end for Q&A. So let's get started. Let's quickly go through the agenda for today's session. We will do an overview of Amazon RDS and the advantages that it provides. Next, we will talk about Amazon RDS Read Replica feature and the use cases it offers, like scaling read workloads, planning a DR strategy, and performing major version upgrades for Amazon RDS for MySQL with minimum downtime. And we will wrap up with a quick demo on how to use RDS read replicas and summary of the session. What is Amazon Relational Database Service? Amazon RDS is a managed relational database service built by AWS to help customers reduce the complexity in supporting critical transactional applications. RDS simplifies the database management by automating the resource-intensive and time-consuming administration tasks such as hardware provisioning, database setup, patching and upgrades, backups, monitoring, and security. So with less operational overhead, your teams can focus on optimizing applications and getting faster results. Amazon RDS gives you the freedom to use relational databases of your choice, including the most popular open source and commercial engines, and Amazon's relational database built for the cloud, which is Amazon Aurora, compatible with MySQL and PostgreSQL. RDS allows you to scale across a global footprint of data centers with enterprise-level high availability and disaster recovery. RDS automates many cumbersome tasks like automatic failover, automated backup, and point-in-time restore. Disaster recovery, encryption, monitoring, and performance optimization are some other tasks as well. These features can be enabled with just a few clicks or some API calls. Next, let's talk about Amazon RDS Read Replicas. Amazon RDS Read Replicas provides performance and durability for RDS database instances and is available for all the flavors of database engines that RDS supports. RDS uses the database engine built-in replication functionality to create a separate database instance called Read Replicas. And then the updates made to the primary instance are asynchronously copied to the Read Replicas. So with RDS, you can create up to 5 read replicas, and those replicas can be within the same region or across another AWS region. You can also create the replicas with multi-AZ option enabled, which provides high availability for your replicas. These replicas can also be used as part of your DR strategy, and you can promote them as a new standalone database in the event of actual disaster. Next, let's talk about some of the challenges for the read-heavy workloads and how you can overcome those challenges using Amazon RDS read replicas. So there are some infrastructure resource limits on how much you can vertically scale your single database instance, which takes both read and write operations. Using read replicas, you can redirect the excess read traffic to one or more replicas, and you can elastically scale out beyond the capacity constraints of a single database instance. Another challenge is serving the read traffic while the source DB instance is unavailable. So in some cases, your source DB instance might not be able to take the IO requests, for example, due to IO suspension for backups or scheduled maintenance. So in these cases, you can direct the read traffic to your read replicas. For this use case, keep in mind that the data on the read replica might be stale because the source DB instance is unavailable. Next, you might have business reporting or data warehousing scenarios where you don't want your reporting queries to run on your production DB instance. So you can rather use the read replicas for such use cases and offload the load of your production databases. In the traditional on-prem database environment, customers use the native replication to keep the databases in sync. And there's a lot of management overhead required where customers monitor the replication lag. With RDS, AWS takes care of replication management and provides customer a CloudWatch metric that can be used to monitor the replica lag. And last is the implementing disaster recovery. So you can promote a read replica to a standalone instance as a disaster recovery solution if your primary instance fails. So RDS makes it easy to create read replicas of your database and automatically keeps them in sync with the primary database. Read replicas are useful for both read scaling as well as disaster recovery use cases. You can add read replicas to handle read workload so that your primary database doesn't become overloaded with the read requests. And depending upon the database engine, you can also place your read replica in a different region from your primary, which may give you the ability to have a replica closer to the particular locality. And finally, read replicas give you ability to have another avenue for failover. So when there is a problem with primary, it gives you the coverage in the event of disaster. You can combine multi-AZ deployments and read replicas to enjoy the benefits of each. So for example, you can configure the source database as multi-AZ for high availability and create a read replica for read scalability. So this is an example on how you can create a read replica with the same availability zone as your primary database. So what we have here is AWS Region 1 and Availability Zone A. And we have created the primary RDS instance and the read replica in the same availability zone. When you create a read replica, you first specify an existing DB instance as the source. Then Amazon RDS, it takes the snapshot of the source instance and creates a read-only instance from the snapshot. Amazon RDS uses the asynchronous replication method for the DB engine to update the read replicas whenever there is a change to the primary database instance. So the read replicas allow only read-only connections, and your applications connect to the replica the same way they do to any other database instance. Let's look into another architecture using read replicas in a different availability zone as your primary database. So in this setup, we have created multi-AZ instance for our primary database in availability zone B. For multi-AZ, there is a synchronous replication between the primary and the standby instance. And your standby instances are not open for connections, and hence they can't serve any traffic from application. And then we have created 2 read replicas in each availability zone. AWS recommends you to create your read replica instance of at least the same size or even higher as compared to your primary database to avoid the issues like high replica lag. But you can create the read replica instance using a different compute size from your primary database instance. So in this scenario, if AZ availability zone A, it goes down, your standby will take a role of primary. But for cases where you don't have standbys, you can promote your read replicas to primary for faster recovery. Finally, we have cross-region read replicas. Creating a read replica in a different AWS region is very similar to creating it in the same AWS region. You can simply select the desired region where you want to create your read replica. Amazon RDS sets up a secure communication channel between the primary database instance and the read replica. So as you see in this diagram here, we have a second region and we have created a cross-region replica in this region. And you can create replicas of different instance sizes based on use case. For example, if you are creating a cross-region read replica as part of your DR strategy, it is recommended to create it with the same compute size as your primary database. This is to ensure that your replica has enough resources and can handle the workload when you promote it following an actual disaster. And for use cases like business reporting, you can create the replicas with higher compute size. Remember, your read replicas handle a similar write workload as your source instance, as well as additional read queries. And here's a visual of cross-region DR implementation. So just like your in-region read replicas, the replica in another region is kept in sync using native asynchronous replication mechanism. And in the event of actual disaster, when you promote the cross-region read replicas, it split off the asynchronous replication process and it begins its own evolution going forward and can now support the read and write workloads. And when you promote a read replica, the DB instance is rebooted before it becomes available. So besides disaster recovery, you can also use the read replica promotion for other use cases like performing DDL operations, for example, adding a new index. This use case is specific to RDS MySQL and MariaDB. You can make your read replica writable after making sure that your replica is in sync with primary. You can create the new index on your replica and then promote it as a standalone primary database and point your applications to the new primary database. So to summarize the use cases of cross-region read replicas, you can improve your disaster recovery capabilities by provisioning the replica in another AWS region. You can scale your applications globally and reduce the performance lag by serving the read workload from an AWS region that is closer to you. And finally, you can migrate your databases in a different region by creating a replica, promoting it to primary, and cut over the applications to point to your new primary instance. Next, let's talk about monitoring the replication lag for your read replicas. So one way to monitor the replication status is by looking at the replication state field on your database instance on AWS console. RDS monitors the replication status of your read replicas and updates the replication state field to error if replication stops for any reason. And once you fix those errors, the replication state is changed back to replicating. RDS integrates with CloudWatch and provide metrics called replica lag for monitoring. And replica lag, it tells you the amount of time a replica DB instance lags behind the source database instance. For MySQL and MariaDB, you can also use the command show replica status, which tells you how far behind your replica is from your primary database. And then you can also use RDS events to get notified if there is any issue with your replicas. Typically, replication delay happens due to reasons like network outage or long-running queries on primary database instance or insufficient resources on your read replicas. You should follow the best practices and offload some of the workload from your primary database instance and make sure that your replica instance have sufficient resources. Next, we'll talk about Amazon Aurora read replicas. Amazon Aurora extends the benefits of read replicas further by employing the purpose-built distributed storage for your databases. So your read replicas share the same underlying storage as your primary instance. This helps with avoiding the need to copy the data to the replica nodes. So the replicas are relatively quicker to create because the cluster volume is shared among all the database instances, and there's only a minimal additional work needed for each Aurora replica, which is to create a compute instance and pointing to the cluster storage. With Aurora, you can create up to 15 reader instances, which is a very good use case for read-heavy workloads. Amazon Aurora includes some high availability features at the storage level by copying the data across multiple availability zones, but Aurora replicas help with increasing the availability further by reducing the failover times. So you can use the Aurora replicas as failover targets, which means if your primary instance fails, an Aurora replica is promoted to a primary instance. If you have multiple replicas, you can assign priorities to your replicas. So if your primary instance fails, Amazon RDS promotes the Aurora replica with the better priority to the new primary instance. So for high availability requirements, we recommend that you create one or more replicas for your Aurora cluster. And additionally, you can also create Aurora replicas from Amazon RDS for MySQL and PostgreSQL engines. So this is the use case if you have requirements to migrate from your Amazon RDS instances to Amazon Aurora. So once you create your Aurora replicas from RDS instance and you see your replica lag between RDS and Aurora replica is 0, you can then stop the replication and make your Aurora read replica a standalone cluster available for reading and writing. So that's for Aurora read replicas. With this, I'll hand over to Adarsha to talk about major version upgrades for Amazon RDS for MySQL instances using read replicas.
Thank you, Supreet. Hello, everyone. I'm Adarsha, and I'm a database specialist solutions architect here at AWS. We are now going to see how the major version upgrades can be done for RDS MySQL instance using read replicas. Amazon RDS provides new versions for supported database engines so we can keep our DB instances up to date. Major versions are infrequent releases and contain new features. In general, a major version upgrade can introduce changes that are not compatible with existing applications. Hence, we need extensive testing when adopting a major version. In most cases, we may have to change application code to ensure compatibility. For example, if your application is using catalog functions or queries in RDS for PostgreSQL instance, you may have to make modifications on the application side as the new major version may have catalog changes. Database engine upgrades require downtime. Whether the RDS instance is single AZ deployment or multi-AZ deployment, it makes no difference on how long the upgrade is going to take. In the multi-AZ deployment, both the primary and the standby instances are upgraded simultaneously. The duration of the downtime may vary for each database engine. For example, when upgrading a RDS for MySQL instance from version 5.6 to 5.7, MySQL forces conversion of all date and time column types to a new format. Because this conversion rebuilds your tables, it might take a considerable amount of time to complete the DB instance upgrade. Hence, it's important to review RDS documentation for the pre-checks, which may help in reducing the downtime. Another option to reduce downtime for RDS MySQL instance is by using a read replica. RDS for MySQL preserves the replication between the source and the replica even after the replica undergoes a major version upgrade. This is a benefit where we can perform most of the maintenance steps ahead of time on the replica while replicating the changes from the source instance. For example, we can create indexes on the read replica. This approach avoids negative effects on the performance of the read replica after it has been promoted to the standalone instance. Additionally, we can test the upgrade process and application compatibility changes without any risk on the replica, and once ready, we can verify if the replication lag is 0 using replica lag Amazon CloudWatch metric and promote the read replica to be a standalone instance. Now let's look at the steps involved in the process. For our use case, let us assume our in production environment has multi-AZ deployment of RDS for MySQL 5.7 instance with backups enabled. The first step is to create a read replica. RDS for MySQL uses the traditional method of asynchronous replication, which is based on replicating events from the source binary log to the replica. By default, the new replica is created as a single AZ deployment with backups disabled. If the target instance ultimately becomes the production DB instance, as a step 2, it's best practice to configure multi-AZ deployment and enable backups to avoid performance impact later. Here we are converting the read replica to multi-AZ deployment. As a next step, we perform the upgrade of the read replica to MySQL 8.0. As you can notice, the replication is still intact even after the upgrade. The step 4 is to perform the cutover. When planning for outage to cutover to the target DB instance, wait for the replica lag to reach to 0, stop the write traffic to the source instance, and check again the replication lag is 0 or not. And then we promote the read replica to replace the original production DB instance by pointing your application to the target. Promotion of the read replica will terminate the replication and will make the read replica a standalone instance. It may seem like a lot of steps, but the key benefits is that you can perform all of these maintenance steps necessary to upgrade your DB instance ahead of time. Therefore, you can reduce the number of steps during the outage to the bare minimum. Now let's look at some best practices. RDS takes mandatory pre-upgrade snapshot before the database engine upgrade. To reduce the time taken for the snapshot during the upgrade process, we recommend taking a manual snapshot prior to the upgrade. We highly recommend testing the database engine upgrade in your dev and non-prod environments to gauge the duration of the downtime and also to verify the application compatibility. If your RDS instances are using custom parameters or options, please check the RDS documentation to verify if the target major version supports these parameters. For RDS MySQL major version upgrade using read replicas, replica lag plays an important role to keep the data durability. If you have high parallel workload on the source MySQL instance, you can consider multi-threaded replication for your target read replica to help reduce the replica lag before cutover. Additionally, if you want to maintain same DNS endpoints for your RDS instance on the application side, you can consider swapping the database endpoints between the source and the target DB instances by renaming. From the application side, please make sure to keep a list of clients and drivers and verify if they are compatible with the new major version before testing the upgrade in lower environments. With that, let's jump into the demo. We are now in the RDS console. Here we will see all the RDS instances and Aurora clusters for the region you are in. I already created a RDS MySQL 5.7 instance. Let us create a read replica for this instance. In the drop-down of the Actions menu, select Create Read Replica. And this takes you to the Create Read Replica DB instance page. We notice that some of the settings are predefined. The reasons for this is it's best practice that your read replicas can be configured same as your source instance. Of course, you can go ahead and change these settings as needed. The first option is to enter the DB instance name. Here I'm going to choose MySQL replica. The second option is to choose the region. For the purpose of this demo, we'll stick with the same region, but you can choose to create a cross-region read replica. Within the instance specifications, select the instance class for your replica. It is best practice to stay on the same instance class as source. You can also choose higher or lower configurations. I am choosing M5 large, which is the same as my source instance. Next, we have storage options. I'm going with the default options, which is the general purpose SSD and 50 GB allocated storage. You have the options to choose the different storage type. Another option provided is the storage auto scaling, which, if enabled, RDS will scale your storage automatically when the utilization approaches near the provisioned storage capacity. In the availability and durability section, you have option to create your read replica in multi-AZ deployment. To avoid I/O latency issues during initialization process, we recommend creating multi-AZ deployment after the read replica is available. In the network settings, we choose the same DB subnet group and security groups as the source instance for the read replica. Next, decide if your read replica needs to be publicly accessible, as this choice determines whether the endpoint can be accessed outside of the VPC. Choose the read replica's availability zone. If you choose no preference, that would mean RDS will choose an availability zone for you. Additional configurations has database port. If your database instances are using custom port, please enter your custom port here. In the database authentication section, we have three options, which is the database native authentication, IAM database authentication, and Kerberos authentication. You can choose to enable IAM authentication if you are going to manage your database users through AWS IAM. You can also set up external authentication for your database users using Kerberos and Microsoft Active Directory. In the additional configuration options, you can specify if you want to copy the tags to the snapshots. Within the encryption options, if your source instance is encrypted, you can launch only an encrypted read replica. If your source instance is unencrypted, you can launch only an unencrypted read replica. Depending upon the version of the engine that you have selected, you are prompted to enable performance insights. Performance insights expand on Amazon RDS monitoring features to help you analyze your database performance. If enabling performance insights, you can choose to specify how long you want to retain the data. The default is 7 days and the long-term retention period is 2 years. The performance insights data must be encrypted. You can encrypt this data by using AWS Managed Key through AWS Key Management Service. Another monitoring option we have is enhanced monitoring. You can choose to enable enhanced monitoring, which will provide 50 new metrics that helps you to have a granular view on your instance health. For this demo, I'm not choosing enhanced monitoring. For some engines, you can enable log exports to export the log files to Amazon CloudWatch for longer retention. Lastly, specify if you want to enable minor version upgrade to have your database automatically upgraded as new minor versions are released. Now once you verify all of the options, you can go ahead and click on Create Read Replica. Creation of Read Replica may take some time. We will now look at how to perform major version upgrade for RDS for MySQL 5.7 using a Read Replica. Here I have a read replica that has already been created and in status available. By default, all the read replicas are created as single AZ deployment with backups disabled. It is a best practice to enable multi-AZ after the instance is created. So to enable multi-AZ, please click on Modify Options. Scroll to the Availability Durability section and choose Create Standby Instance. For backups, set backup retention period to non-zero value. Here I am choosing 3 days and then we choose continue. And in the scheduling of modifications, choose apply immediately. Enabling multi-AZ may take some time. Here I have a read replica that is already enabled with multi-AZ. Let us choose this read replica and upgrade this instance. To upgrade a read replica that is already in multi-AZ, you can click on modify. In the DB engine version, choose the target engine version as MySQL 8.0.23. Scroll to the end of the page and then click on continue. In the summary of modifications, we notice that the DB parameter groups and option groups are changed to the new value, which is so that it can support MySQL 8.0. If you have custom parameters or options, please create new custom parameter group and add them explicitly in the modify page. In the scheduling of modifications, choose apply immediately and click on modify DB instance. Upgrading of the database may take some time. I already have a MySQL replica which is upgraded to 8.0.23. Let us verify the replication options for this replica. We can verify the replica lag in 3 ways. The first one is choose the connectivity security tab and scroll to replication options. As you can see, all of my read replicas are replicating, and this is the current replica which we are verifying. And the second option is through command line. You can connect to the read replica and then run show replica status on this replica. As you can see, now I am connected to the read replica. Let me run the command show replica status. As you can see, the seconds behind source is now showing 0. This means my replica is not lagging behind. Alternatively, you can choose to review the replica lag in the RDS console in the monitoring section. You can filter out for the replica lag metric. And as you can see, the replica lag is showing 0 here as well. Now let us promote this read replica to make it a standalone instance. To promote the read replica, go to the Actions dropdown and click on Promote. In the options, I'm going to enable automatic backups. I'm going to choose the default backup retention period as 1 day, and I currently don't have any preference for the backup window. You can make these modifications as needed. Click on Continue. When you promote a read replica, the replication is stopped from the source to the read replica, and the read replica is rebooted as part of promotion. Once you're sure, you can go ahead and click on Promote Read Replica. The promotion may take some time, but we have successfully upgraded our RDS MySQL 5.7 instance to MySQL 8.0 using Read Replica. That concludes my demo. In this webinar, we saw the benefits of using RDS Read Replicas for use cases such as disaster recovery, performance, and availability. We also saw how we can leverage read replicas to perform major version upgrade for RDS for MySQL instance. In the demo, we saw how easy it is to create a read replica, and we performed a major version upgrade for RDS MySQL 5.7 instance using read replicas. Thank you everyone for joining us today for this webinar. If you have any questions, please use the chat sidebar to ask any questions as we are going to spend few minutes answering the questions of the attendees. Thank you very much.